Full Stack Desk.
And you're watching this video because you want to build your own AI voice assistant utilizing LiveKit. Well, you want it to be as simple as this: hitting npm run dev here, and then hitting this command here, heading over to your local environment and starting a conversation with LiveKit as so. Hey there, how are you doing?
I'm doing well. Thank you. Subscribe to Full Stack Desk on YouTube. AI content is quite popular and valuable. Good luck with your YouTube channel, Full Stack Desk. Is there anything else you'd like help with?
So today we are going to cover integrating OpenAI with LiveKit as we build our own AI voice assistant from beginning to end. Please hit the subscribe button since this channel predominantly covers the latest AI tech software news. Also, feel free to join my Discord. We have an AI tech family and I'd love for you to become a part of it. Dr. Fullstack from Full Stack Desk, let's begin.
Okay, so let's cover, how does LiveKit actually work? Well, we're going to set up either a mobile or web application that our users can interact with. Maybe it'll be a voice agent that they'll speak to. This web client, let's say it's React.js, or let's say you're using Swift for iOS development with Apple. Well, in this case, we're going to establish a WebRTC connection with LiveKit's cloud. Now, LiveKit's cloud is just their edge network. This is going to allow us to be able to send voice audio or video in a really fast way, despite how far away the users are. Because a lot of times we're sending this data within packets all over the internet, and that's simple when it's just text. But when it comes to audio and video, well, these are really dense packets of data. And even with video, we're looking at 4 forms of data. We've got the actual video images itself, which we have a frame of images. Then we have the actual voice, which is the audio. And then we have a timeline so that it knows how to arrange these actual bits of data. And lastly, you might have some metadata for that actual video. So a lot of that is going to get ripped apart, disassembled, and sent over the internet in packets and then reassembled once it reaches the user. So LiveKit is going to allow that to happen in a much more simpler and streamlined way. Here we see that, again, we have our client is going to communicate with LiveKit using WebRTC. WebRTC is a way that you can establish a connection between 2 clients utilizing a peer-to-peer connection, which is different than establishing a WebSocket connection. There you're upgrading the actual HTTP connection protocol that we normally would use for TCP. You're going to upgrade that to a bi-directional connection, whereas HTTP is just unidirectional. So once this happens, we can now send messages with that WebSocket, but let's get back to WebRTC. WebRTC, we're going to establish a peer-to-peer connection. It's really, really fast. It's new browser technology. And honestly, you're going to see it a lot more than usual. Here, we established this WebRTC connection to LiveKit's cloud. As I mentioned, is the edge network. LiveKit cloud is also going to establish a connection with our backend server. Okay. So this could be Node.js, this can be Python. You decide what you want to utilize for the backend. So once you've established that WebRTC connection, here we have our client and our backend talking to LiveKit Cloud. Now our backend is also going to have another connection utilizing a WebSocket. So this is with OpenAI's Realtime API, which you know that utilizes a WebSocket framework. So here we see that it says WebSocket is not ideal for real-time audio and for real-time audio and video over long distances or slower networks. LiveKit bridges this gap by converting the transport to WebRTC and routing data through our global edge network to minimize transmission latency. So here, notice that our client never talks to our backend. Okay. The client only talks to LiveKit's cloud server. LiveKit's cloud service was going to speak to our backend, and our backend is going to speak to OpenAI Realtime. Notice OpenAI Realtime never actually speaks to LiveKit Cloud. It utilizes our backend server. So these are really important things that you should understand about the architecture. Now you can just go and build the application. That's your call. But I think by understanding the architecture, you can now customize things and even improve on this current development. So here, LiveKit bridges this gap by converting the transport to WebRTC and routing data through our global edge network to minimize transmission latency. With the agents framework, user audio is first transmitted to LiveKit's edge network. Hey everyone. So everyone's been asking me to do a new LiveKit tutorial, so you guys are in luck. I'm going to do an entire LiveKit tutorial from beginning to end so that you guys can set up your own AI chat assistants. And if you guys need any help, just hop into my Discord. As you've seen in my past videos, I'm willing to help anyone. I'll hop in a one-on-one call with you and unblock you so that whatever bottlenecks you're facing, you can cast those to the side and build your application for success. So with that being said, we're going to get started. I'm going to start upon signing in with my Google OAuth. LiveKit is going to ask me to agree to their terms and services. I'll go ahead and agree. And for my first app, I'm going to name it Full Stack Desk. Now let's hit continue. Awesome. So I'm just going to say just me, and I'll say AI. For this, we're going to say no. We're going to say ease of use, and then we're just going to say GitHub. Let's say finish. Awesome. So now we have our LiveKit environment. So if you've reached this point, you're in good luck. WebSocket is not ideal for real-time audio and video over long distances or slower networks. LiveKit bridges this gap by converting the transport to WebRTC and routing data through our global edge network to minimize transmission latency. With the agents framework, user audio is first submitted to LiveKit's edge network via WebRTC and routed to your backend over low latency connections. The agent then uses the agent's framework integration to relay audio to OpenAI's model via the WebSocket. Similarly, speech from OpenAI is streamed back through the WebSocket to the agent and relayed to the user via WebRTC. So here we see that the agents framework has everything that we need to build conversational applications using OpenAI's real-time API. They've got a Node.js instance and they have SDKs for virtually every single platform. Now here they're covering inbound and outbound calling using SIP trunks. They're also covering WebRTC transport via LiveKit Cloud or self-host OSS, workload balancing, and request distribution. Here it mentions the agent lifecycle. Now here are some concepts that we'll have to understand. The LiveKit agents framework uses the following concepts. Room, a real-time session with participants. The room acts as a bridge between your end user and your agent. Each room has a name and is identified by a unique ID. Next, we have participant, a user or process, example is an agent, participating in a room. Agent, a programmable AI participant in a room. Track, we have audio, video, text, or data published by an agent or user and subscribed to by other participants in the room. Multimodal agent. The framework includes the multimodal agent class for building speech-to-speech agents that use the OpenAI Realtime API. To learn more about the differences between speech-to-speech and voice pipeline agents, see voice agents comparison. So here at first glance, looking at the LiveKit environment, we see that we have analytics, sessions, agresses, ingresses, settings, sandbox, which is in beta, and billing. Well, what we're going to need to do is create an agent. So this will allow us to build our first LiveKit agent in under 10 minutes. Here it states that we we can do an OpenAI Realtime API integration guide. And then these are some other options that we have. Let's go ahead and click on this one. Within here, we have OpenAI Realtime API integration guide. It's going to allow us to check out the playground. And then we have a guide on how to use OpenAI's real-time API with LiveKit's WebRTC infrastructure. So we can go through all of this documentation, but if you've seen any of my other videos, then you should be in great shape. At this point, let's just begin with a Node.js instance. I'll go ahead and download said application. Now that I have that, I'll click on it. Now, at first glance, I know that a lot of people are going to wonder, where do I start? Well, you can head over to the README, which is right over here. And this explains a bit about how to set up the installation. Here, we immediately see that in order to install, they want us to use PNP, which you can set up if you haven't set up already. Next, we see that it's going to ask us to set this as our environment variables. And then lastly, in order to actually start the agent, we see node my_agent.js space start. Here it states, when using the playground for our agent AI, rather agent UI, well, to ease the process of building and testing an agent, we've developed a versatile web frontend called Playground. You can use or modify this app to suit your specific requirements. It can also serve as a starting point for a completely custom agent application. Here we see a hosted playground. Here they also provide the GitHub source code, and then there is the documentation. It states a bit of jargon here as far as joining a specific room, but I'm sure that you guys don't really care much about that. So let's just go look at the main code that's going to get instantiated when we hit start. Your main files to be aware of is the multimodal_agent.ts and the pipeline_voice_agent.ts. Those are the two files that we're going to focus on.